Hi, this is Compression Art and this is episode 1. Okay, let's talk about what is compression. Compression is the act of compressing information so it can fit through a connection that we have that has a limited capacity or fit on the media for storage. So all we want to do is compress this information as the name suggests to make it smaller. So we have to talk about the information first. What is information? So I have to cover some basic. I assume you have a little bit of probability theory background. So what is information? Information is something that happens. So when you hear something on the news, it's something that happens, like somebody crossing a street, but it has to has an amount of surprise about it. They don't mention if something is happening every day. They don't mention it in the news. It's not that informative. There has to be some amount of surprise, and surprise if is about something that's rare. So if something with a probability of 1/10 or 10% happen, you're a little bit surprised. If this thing happens again, we are again surprised same amount. So if it happens both times, we are double surprised, which means that the amount of surprise we have is the sum of the surprises that we did for the first time and the second time. And if we assume they are probabilistically independent, the probability of that both events happening is the product of probabilities, which is 1/10 times 1/10, which is 1/100. Surprise of a rare event is something, and when it's happening twice, we are twice surprised. So it assumes this exponent is somehow linearly combined, measured in the amount of surprise. So it suggests that the logarithm of probability of event is the amount of surprisal. And since we know from math, let me show this formula. This is a theorem that the exponent in the logarithm function can be considered an outside multiplying factor. So it makes sense to consider this as the amount of surprisal, the logarithm of probability. And the base 2 is just a convention, so the units measure, everybody doing the same thing. What we want to do, we want to actually calculate the amount of surprisal that on average happens for an event. And doing it very easily, we can average it over all the events. So if we have like multiple events that have the same, different probabilities, we can average the surprisal, and they call it entropy. And Claude Shannon showed that this is a good measure for how much information is in a random variable or an event that might happen. When we do compression, we are going to see this measure as something that will be the limit of the compression we can achieve without adding more assumptions. And it's measured in bits. That's the reason this base 2 exists here. If it's in base 2, they say it's in bits. If it's not in base 2, you cannot say it's in bits.